Hi, in this video we're going to be looking at dynamic equilibriums. There is more content, quizzes and past papers on the website, which is www.elevise.co.uk. The previous video looked at the reversible reaction, so have a look at that one first before coming on to this one, but here's a quick summary. A reversible reaction is a reaction that can go in both directions. So here we've got an example where you can see that A and B can react to produce C and D, and also C and D can react together to produce A and B. If this reaction is taking place in a closed system, eventually it will reach a dynamic equilibrium. A dynamic equilibrium is where the same quantity of A and B reacts together to produce C and D as the quantity of A and B produced from the reaction of C and D. There are still reactions taking place in a dynamic equilibrium, it's just that the concentrations of the substances remains constant. The dynamic equilibrium does not have to be where the mass of all the substances are equal. Instead, it can be either to the right or left of the equation. We usually refer to the substances on the left as reactants and the substances on the right as products. We can also describe where the position of the dynamic equilibrium is. If there is a lot of products relative to reactants, we say that the equilibrium lies to the right. If there is a lot of reactants relative to products, we say that the equilibrium lies to the left. So what factors influence the position of the dynamic equilibrium? The dynamic equilibrium is dependent upon temperature, pressures when we're looking at gases, and then finally concentration. If we change any of these variables, the equilibrium position would move to counteract the change, and it will move back to the state the reaction prefers to be in. So let's start by having a look at temperature. The effect that temperature has on the dynamic equilibrium is dependent upon the type of reaction. Reversible reactions go in both directions. One of the reactions is going to be endothermic and the other reactions is going to be exothermic. Endothermic reactions mean that the energy of the product is greater than the energy in the reactants, and exothermic reactions are the opposite. It means that the energy in the reactants is greater than the energy in the products. So let's start by having a look at an increase in temperature. An increase in temperature will move the dynamic equilibrium towards the endothermic direction. This is because the endothermic reaction will take place to remove the extra heat that has been added. A decrease in temperature will move the dynamic equilibrium in the exothermic direction. This is because the reactions in the exothermic direction will increase and this produces heat. This pushes the reactions back to the original temperature. The next factor that we're going to look at is pressure, and pressure is only relevant for gases. Pressure is a force per unit of area. We can increase or decrease the pressure that a reaction is taking place in. If we increase the pressure, the dynamic equilibrium will move to the side that produces fewer gas molecules. This is because the reversible reaction will want to move its pressure back to what it was before, and having fewer molecules reduces the pressure in the container. If we decrease pressure, the dynamic equilibrium will move to the side of the reaction that has more gas molecules. This is because more molecules will increase pressure, thus moving the pressure back to what it was before the pressure was changed. The final factor that we're going to look at is concentration. Concentration refers to the mass of the reactants or products. If we increase the quantity of a reactant or reactants, the dynamic equilibrium will move towards the right. This is because there is now more of the reactant or reactants, which means that more of the products are produced, thus moving the equilibrium towards the right. If we decrease the concentration of the reactants, the equilibrium would move towards the left. This is because there is now more C and D relative to A and B, and more C and D will react together to increase the quantity of A and B. We can also change the concentrations of the products, and I have gone through that on the website. There is a link in the description below which will take you through to the website. The website is www.elevise.co.uk.